Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on November 10th, 2025, about 2 days ago. This paper introduces PhysWorld, a framework that turns video-generated demonstrations into physically executable robot actions, and in real-world tests, it achieves an average success rate of 82% versus 67% for the best zero-shot baseline. The paper is titled, Robot Learning from a Physical World Model. And as we will see later, the combination of video generation, physical reconstruction, and residual reinforcement learning opens a path to data-free training that scales. Alright, the introduction set the stakes with data-free training. Figure 1 presents the full pipeline. A single scene image and a text command flow into video generation, then physical world modeling, and finally robotic manipulation. The left column depicts the input scene. The central panels illustrate task-conditioned video frames that imply motions. The orange column shows reconstructed objects and ground alignment, which enable physics. The purple column demonstrates the robot executing feasible actions, while Figure 1 sketched the pipeline at a high level. Figure 2 shows the concrete flow from image and task prompt, to task-conditioned video, to physical world modeling, and finally to zero-shot execution. The left column provides the single RGB and depth inputs plus the language command. The central panels detail four-dimensional reconstruction, textured meshes, and object-centric learning that grounds motions into physics. The right column presents real robot steps that pour the tomato into the plate. So the previous figure laid out the pipeline step by step. Figure 4 shows success rates across 10 real-world manipulation tasks, and the blue bars consistently lead because the policies learn inside a physical world model. The average success reaches about 82%, compared with roughly 67% for the best zero-shot baseline. Tasks like put the book in the bookshelf and pour the tomato onto the plate show especially large margins. Okay, the previous figure reported success rates across tasks. Figure 5 presents qualitative rollouts that connect inputs, generated guidance, and executed behavior. The left column shows single-scene images that set each task context. The middle column illustrates task-conditioned video frames that suggest object motions, which provide rich visual hints. The right column demonstrates the robot completing the same tasks in the real world, so the visually implied motions translate into feasible, zero-shot actions. So the previous figure linked visual guidance to real executions. Table I reports generation quality across models, measured as the share of usable videos. Veo 3 reaches about 70%, Tesseract delivers roughly 36%, while Cog Video X 1.55b and Cosmos 2b trail at about 4 and 2%. The large gap matters because higher usable rates mean more scenes where object poses can be recovered robustly, which translates into more reliable manipulation. Alright, 2 takeaways stand out. Coupling video generation with a reconstructed physical world turns visual hints into executable actions, and object-centric residual reinforcement learning delivers strong zero-shot manipulation without real demonstrations. The broader implication is scalable robot learning that benefits directly from better generators and higher fidelity simulators. Thanks for listening. I am Alex.